All right, so what I'd like you guys to do, all right, so this video is going to teach you how to label a pedigree. What is a pedigree? A pedigree is a diagram that shows you the inheritance of a trait over generations. So each line here represents a generation. This line 1 is the first generation, and there were the parents here, okay? A lot of times, yes, a marriage or a partnership that resulted in children. The circle is a female, and the square is a male. And a line that happens between the two, that means that they had a relationship that resulted in children, and these are the children they had. Okay, so how many daughters did they have? 2. And then how many sons did they have? 2. Daughter, daughter, and then they had son and a son. All right, and then the other thing that you might notice is that one of their children had a relationship that ended up with 3 children. These children over here were identical twins, so they come from the same point, and then they had another offspring here. So what we want to do is, a lot of times when I give you a pedigree, I want to know the trait that it's displaying. How was it inherited? Was it recessive or was it dominant? So a recessive trait would be little r, and it means that each parent has to carry the trait. So let's just say, for example, that we think that this was a recessive trait. Okay, I kind of have a 3-step system in solving pedigrees. The first one is to label everyone you think is recessive, recessive. So with the 2 recessive alleles. The second one would be label the other individuals with a dominant allele. So what do I mean by that? Label everyone you think is recessive, recessive. So if we think this trait is recessive, I would say, all right, this would be little r, this would be little r, this would be little r, this would be little r. Okay? So now that's step 1. Then step 2, label everybody else with at least one dominant allele. So big R, big R, big R, big R, big R, big R. Okay, so now everybody's labeled as well as I can do. Now I have to use the information from the pedigree to figure out what everybody else is. So for example, I'm going to start at the bottom. A lot of times I start at the bottom and work my way up. These 3 kids are little r. We know they got a little r from their mom. What did they have to get from their dad? A little r. Okay. So now I'm going to pop back over here. I know that I don't know what the 3 alleles are yet from the 3 siblings on the left side. But I do know that this daughter was little r. Who did she get those little r's from? Each one of her parents. All right, so each parent from the first generation was big R, little r. So what did they give this daughter? We don't know. What did they give this son? We don't know. We don't know. And that's because if this parent, if the mom gives a big R, dad could have given a big R or little r. And we don't know because it could have been a big R or it could have been a little r, but it would still be the same result. And the trait wouldn't be filled in because they don't carry that trait. So the third step, I guess, in our method is to try to determine the genotypes of the dominant individuals. Okay? So that is how we go about a pedigree. I'm going to practice with you 2 more times before I set you loose. I'm going to erase this here, keep our method. All right. All right, so here is the next one, and I'll erase our steps in just a second. But remember that we are going to label who we think is recessive, label all the other individuals with a dominant allele, and then try to determine the genotypes of those dominant individuals. Okay, so those are the steps we want to remember. This case, it actually tells us that in the upper left-hand corner, it says big A can taste PTC and little a cannot, and that's the trait we're following. So everybody that has a black circle or square carries the trait. So that's what we're going to label. The trait is a recessive trait. So that means everybody that's carrying the trait is little a, little a. Now, I want you to be careful, and I'm going to say this again. You need to pay attention to what the trait is, If it said the trait was dominant, everybody that had a black circle or square would have a big A. But because the trait is a little a, they're recessive. I'm going to say that one more time because it's super important. If it says the trait is dominant, everybody that's black will have a big allele. But since the trait here is recessive, we know that everybody that has a black circle or square is big A or little a. No, just kidding. Everybody that has a big square or big circle is little a, little a. All right, so then we're going to go through and label everybody else with at least one dominant allele. All right, so we can go through and do that. And then our third step is to go back and try to determine if the individuals are heterozygous or question mark. We will never, ever, 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 ever label somebody big A, like I just did. You will never have that because you'll never know for sure if somebody is heterozygous or homozygous for the dominant trait. Okay, so again, I like to start at the bottom. So I'm going to pick down here and start here. If those children, those boy twins, are little a, what did they have to get from their parents? They had to get a little a from each parent. So they got a little a from dad and a little a from mom. What did they give to their offspring? What did mom in particular have to give to her offspring? A little a. So we know the sisters down here are also little a. All right, I want you guys, before I give you the answer, try this on your own. So what you should notice is that this dad is little a, so he's going to give all of his offspring a little a. The daughter here is little a, so she had to get that little a from her mom. All right, and then what about over here, this part of the family? So we know that dad is little a, so had to give a little a to all of the offspring. So what about mom here? Do we know if mom is big A, or big A, little a? And the answer would be no, we don't. Okay. So we don't know if she is homozygous or heterozygous dominant, so we are going to just put a question mark. Or you could write a dash and leave it blank. All right. All right, so the last one we'll do is the trait for albinism. And albinism is the trait. If you don't know what the trait is, so let's say I gave you normal skin and albinism and you weren't sure if we were following normal skin or we were following albinism, you could find out. Because let's say that I think all of the people that are not filled in are recessive. Is there any way you could have number 6? Because if 3 and 4 are recessive, then D or 6 would have to be a big D because it's the opposite color. But there's no way that this number 6 could have inherited a big D because the parents are little d, little d. So you can also figure it out if I don't tell you. Okay. So albinism, though, is the trait here. So little d, little d, little d, little d, and then we go through. What do we know everybody else is? So the first step is to label everybody we know recessive, recessive. The second step is to label everybody else with at least one dominant allele. And then the third step is to label everybody else with that dominant allele. Is it a heterozygous or do we not know? So this guy would be little d because gave a little d to the daughter. These parents here have to be heterozygous. And everybody else we don't know. So everybody else would be a question mark because we don't know for sure. Yeah, probability says that these guys are probably homozygous dominant, but because we don't know 100%, we can't list it. So your job today is to finish this packet. It is homework if you don't finish it. Hold on to it. Please don't hand it in, but hold on to it if you finish it. And skip the problems that have to do with sex-linked traits because we haven't got there yet. But most of it you should be able to do. All right? Thank you.